So now I've completed setting up some of the other controls in the face. I've added one for the top lip. It pulls on several joints, even the one up here in the cheek just a little bit, the one just underneath the nose, and two across the top of the mouth. Same with the one below. It's pulling now on the ones on this side of the face. I haven't hooked up the left side of the face at all to it, as I'm going to show you how to mirror some of these controls over and reset some of this up. One for the cheek now, handles the cheek and underneath the eye a little bit, moves some of those around. And of course the mouth and the side of the face here that we had before all working. You can see getting this nice flexible face system go to work. It's quite interesting actually seeing it work without all the geometry on there and see it all deform and flex. And this is looking pretty nice. We're getting a pretty flexible looking face setup. A couple things we're going to do to complete this basically is one, we have to do the left side first off. So let's figure out how to actually set all this up on the other side so it's exactly the same. And part of the issue we're going to have with this is that if we don't get this exactly the same, we'll get completely different results. And we've been just arbitrarily rotating some of these control points and some of these control objects to be able to set up the other side. So what we need to be able to do is we need to be able to somehow mimic these rotations on the other side of the face and make sure that they are exactly as we would expect them to be. So what we can do to do that is we can use a little bit of script, and we can use quaternion values. And most people don't understand quaternion rotations completely. The way quaternion rotations work is not like an Euler rotation. It isn't an XYZ value. It is an XYZW value, but the XYZ is not what you would expect in most cases. I'll give you a bit of an example of what a quaternion looks like. There is more information on my website about how they actually function and work, so you can read that as well. Let's pretend we've got a sphere, and let me just make sure it's sitting at 0, 0, 0. And let's say that we have a pointer that sits at 0, 0, 0 as well in this case. Height. Let's make it touch it. And I'm just going to make this transparent, see-through, just as for our example here. Go back and I want to grab the cylinder. A quaternion value is based on the point at which that cylinder touches the sphere. So when you rotate an object, you're not actually getting a rotation value XYZ here. What you're getting is that point on the sphere there, which has been normalized. So it is based on that position, and this pointer points at that position on the sphere somewhere. This is why you can't have function curves quite the same as you can with an Euler, because you really can't wind it up. You sort of have 0, 0, 0. You have the opposite side of it, which is at the bottom, and as you come back up, you go right back around to 0, 0, 0. And essentially, you can never have values that represent anything more than a unit vector. And that unit vector is the distance between the center of the sphere to the point on the sphere. So you can't have the XYZ values of a quaternion can't actually go higher than a value of 1 in their length in a unit vector. The fourth value is actually this value. It's the twist around, and it's a value from 0 to 1 that represents the rotation, basically the twist around that vector. And that is what a quaternion is based off of and how it works. Now the advantage of it is it's actually better math. It's actually more accurate. Euler values are very inaccurate math for all intents and purposes. They don't really represent a good way of dealing with rotations in 3D space. They are great for animators because they have function curves. However, they are prone to problems like gimbal locking, as I'm sure most people have run into at some point. Quaternions don't run into that problem. However, they run into other issues like not having function curves. And so there's good points and bad points. You need to know when to use which ones. For mirroring a rotation, because we don't want to actually mirror these controls, we don't want to actually have to put a mirror on them. Mirroring them would actually put a negative scale value on them in the X, let's say, is because we're going across the world X-axis here. And that would invert transform matrices and whatnot, and that is not a good thing. Again, you can read up more about that on my website, but you want to avoid scaling objects, and that means mirroring them across an axis. So what we want to be able to do is do the same thing that the Mirror Bones does. Mirror Bones in the Bone Tools dialog right here doesn't actually mirror a bone. What it does is it rotates it into place. So we actually mirrored this joint to this joint. And if we look at the local axes of both of these, you can see that what it's done, it's taken the object and rotated it over into place. It's actually mirrored the, in this case, the Z and the X axis, and it hasn't mirrored the Y. It's what's called flipping it, basically, so that you're rotating the object over into place. Now what we want to be able to do that is with a control object here. We want to be able to take this control object and have it end up in exactly the same spot on the other side. So what I'm going to do is I'm going to use my listener right now. Actually, let's start with a script. Let's start with a new script. We need a couple of pieces of information here. We need to get the position and rotation of the original. So I'm going to say pause equals $.pause. And that returns the position vector of it. We're going to then get the rotation equals $.rotation. And that returns a quaternion value. And there's those values I'm talking about. You can notice that none of them are high values. That's because that is a vector on that surface of the sphere, and the length of that vector, those first three values, is a value of 1. So it's a normalized or a unit vector, it's called. And then this is the value from 0 to 1 that represents the twist along that vector. Basically, along the length of it, it shows that number. So what we need to do now is because these are vectors in space, they are points in space, we can actually use this and simply flip them over. Rotations are very inaccurate. An Euler rotation is very, very inaccurate, and trying to actually rotate it with Euler angles into the right spot on the other side would be next to impossible to get it right. These are actually position values for all intents and purposes, and it's easy to flip over or make a position value mirrored from one side to the other. So what we're going to do is we're going to take this quaternion value that was added, we're going to say $.rotation equals, we're going to go pick our new object here, and we're going to say $.pause equals pause. We're not going to use the rot variable we've created right now. But what I'm going to do is show you how to do this. So I'm just going to take these two and basically mirror them over. This is done by going, the position is done by times -1, 1, 1, 1. So I'm going to multiply the position value by this, and that drops it on the other side perfectly. The rotation, what I'm going to do is, believe it or not, it's this simple. All I'm going to do is take the negative signs out of the y and the z values. That'll send it off into space somewhere and then reset the position. You notice I put that next. But if you notice now, it's actually rotated in the opposite spot. It's literally that easy, and it's been rotated over. Now, the method I've used basically will mirror it across that one axis, and it'll flip the x. So you can see the x is currently not mirrored in a sense. If you look at it in world coordinates sense, the x value here, which is the point right there, has been taken all the way over to here. So that's actually not mirrored because it would be here instead. And we don't want that. One of the axes can't be mirrored. The y and the z have been mirrored. They've been mirrored over across that center axis to the right spot. And so that's rotating it into place, essentially, rotating that object over to where you'd expect it to be. So now what we need to do is figure out how to actually work some of this math so that we don't need to go about doing that. Let's do something just dead simple, because we know that we're just going to use this simple math. This, of course, what I'm showing you won't work for everything all of the time. There's a lot to take into account, like hierarchies of objects, what things are parented to, but it should work for our solution. So I'm going to use the rot value now, and I'm just going to put rot.x, because rot.x will return the first value of the quaternion. For the y, I'm going to give it brackets. I'm going to say rot dot y times -1, and that will invert the rot value. So if we have, that's the rot value, the y value on the rotation, just going to invert it. I'm going to do the exact same for the z. So rot dot z times -1. And that will flip over the value. And of course, the last one is rot.w. Believe it or not, actually gives us the final value in that rotation. So what we can do now is we can do this as a two-step thing. We can say, let's take this object, just copy it. Let's pick this one here. Let's get the values. Let's set the values. And there it is, mirrored over to the other location on the other side. Now, to make that a little bit more useful again and a little bit faster to use, let's write this. So we have get obj equals selection 1. Copy that down and say set obj equals selection 2. And I want to change up our dollar signs here. And so what I can do now is I can grab, just copy one of these, or if I wanted to make a new one, I'm going to grab them in order. The one that I want to get from, the one that I want to set to, I want to evaluate the script. And it pops it on the other side. So the first one in the selection, the second one to the second one in the selection. And there's our mirror script for mirroring over objects. Essentially, it'll mirror anything as long as they have the correct parents. They have to have the same parent objects, and it'll be able to mirror them across to the other side. So now what we need to do is we need to go about setting up the other side and using this script just to make sure that when we set up a new point helper as a group node, as I've been using this on the other side, we want to get the orientation exactly the same. I just need to select the one on one side, select the new one on the left side, run the script, and it will reorientate this one the way that I expect it to be. And then all this will run as you'd expect. And it should be a quite nice way to have it all working. So what I'm going to do is I'm going to go ahead and finish setting up the other side of the face to get it all working the same as the right side. And then we're going to do the eyebrows and the lower brows and the eyeballs all in one shot. The eyebrows are really pretty much all the same sort of thing. At that point, we're going to probably write a little script to go around and set up controls for each of the joints positions where we've got them, so that we can go and set those up really quickly and have each one of them set up with a little control object, so that we have that lower level set of controls that basically handles each joint individually. So let's just take a look at what I've done here in setting up the other side of the face. I made a few changes along the way. One of the notable ones is with the rotations on the sides of the mouth. I actually removed the rotations from these joints that we'd initially set up and completely took them out. They really weren't needed. I added it to the other side, obviously. The other one that I made a change to the initial structure is that I added rotations into this one so that it twists the top lip. To get this to work correctly, you actually need to change how we set up the look at constraints. We set them up on the objects, and we set them up with an up node, and the script we set up set the up node to be the point helper that we'd put at the parent end of the joint. Well, this control is really moving the child end of the joint. So what I did is I changed the up node to be the point helper that it was looking at, so that when we rotate this now, it actually twists those two top joints. The bottom one I didn't have to do that for because the bottom one was set up with the parent joints, and this one's rotating the parent joints, basically the parent end of it, so it rotates as we expect. Now we can curl the lips in and out, so you can actually get some lip curl. Still haven't dealt with any weighting. You'll notice that the top and bottom controls are pulling the too much and overlapping things. So one of the last things I'm going to do is go in and tweak all of the weighting so that it comes up better. I've set it up so that now the top lip is pulling on what you'd expect. I changed up the bottom lip a little bit, that it actually pulls on this control and pulls it down a little bit as well now, which meant that I had to go and set this joint up as I did these ones, with that loop back on the position. So the position wire and the third track wired back so we don't get double transforms. And its parent object is now parented back into the actual control that it controls. So that when you pull on the bottom lip, you're actually getting the corners of the mouth being pulled down a bit. And when you're pulling on the top one, it doesn't, but it's pulling up around the nose a bit. I even have it now set up so that when the cheek moves, it's actually moving this one a little bit, and this one moves that one a little bit. So it's actually this kind of cool way of setting it up, that it seems like sort of a dependency loop problem, but it really isn't causing a dependency loop that's going to slow anything down. The rig is very fast still. It deforms the face very quickly and doesn't have a problem at all. So that's quite nice. There's a few changes I've made there and played around with it, just trying to get some subtle things working a bit better. And the next thing I was going to look at doing is getting into the eyebrows. Now what I've done is I've already gone and set up one of the eyebrows, copied a control up, and the control is parented to the base joint of the jaw. It really doesn't matter anywhere. The head bone would have been fine. And I'm just going to show you how I've set this up to work then, which is quite a neat control system. I wanted to actually have one control for the eyebrow and set it up so that it was nice and simple for the animators. What's great is you can pull it up and down, and you get both ends of this joint essentially being dragged up and down. And what's nice though is if you pull it sideways, I've set it up so it pulls these joints a little bit sideways. So this one not so much when you go this way, and then the other way around. When you go the other way around, this side moves more than this side once you go this way. I'm not even sure that's entirely needed. They may not need to move side to side at all, but I've got it that way right now just to see how it works. And then what I've got is an interesting system that when you pull it up and you start pulling sideways, you can see that the outer edge of the brow starts going down, and actually the point where it starts going into a negative value. And when you bring it back, the inner one starts doing the same thing. It starts going down. So you can actually completely change up the attitude of the eye just by dragging it sideways. And same thing in the down position. Now I'm not using Reaction Manager for this like I did with the Morph system. This is all done with wiring, and it's strictly wire dialogues that are handling this. So what's nice is you can get a real change in attitude going, and the amount that you want the other side to drop is based on how far you pull it sideways. So it's quite a flexible system. So we're going to set that up on this other side and get that to work as well now in the next AVI. So there's some of the basic changes so far. Another change I'd just like to point out is in one of the scripts, mirror objects. Something I realized as I was getting into it and starting to mirror over from one side to the other is that once I grouped the red point helpers here with a new point helper, and we needed to rotate it into place and make sure it was rotated the right way, you need to have Don't Affect Children on. The only problem is when you set the rotation of an object through script, it completely ignores this. This has no effect on it at all. So when you set it, it automatically just rotates the child objects. So what I did is I made a quick fix here in our mirror tool. I added a new parameter to it so we can turn it on and off through the switch if we want. Don't Affect Children false. And so what this does is add a parameter to it called Don't Affect Children, and it's defaulted to false. What I could do is I could actually have one here. If I just run that, it'll be false, but if I add the parameter to it, I can set it to true. And what don't affect children does basically is it's going to go in, and regardless, right now it's doing this portion of it, but it's getting it's getting the selection, which is the first object you picked. It's getting the second object from the selection, which is the one we're going to set the change to. And what it does is it runs through, and it says for X and set objects, so the one we're going to put it on, gets all the children and collects the child objects, and it collects the transforms and dumps them into this array here. So for X in set obj.children, collect X.transform. So it collects all the transforms of the child objects. We go through and we do our mirror, which unfortunately will rotate the child objects as well. And then here we simply do an if don't affect children is equal to true, and this is the fast way of writing it, just if don't affect children. So if true, then what I do is I loop through the children objects, the child objects of the one we're setting the rotation value on. And so I say I is equal to 1 to set obj.children.count do, and then set obj.children I dot transform is equal to the corresponding transform matrix that I stored in this array here. And basically I rotate them back, as all intents and purposes I set them back. The dot transform property of an object is in world space, so this worked and it basically set them back. So this is my solution to don't affect children not working here. So we could use that to be able to reset them on the other side and make sure things are rotated as we'd expect on the other side. I wanted to be able to set it true or false and just not have it on all the time, because then I can use it for mirroring the control over, where I want to make a copy of this over, but I want to actually make sure that the child objects do rotate with it and move over with it correctly. So I can turn it on and off, either run that line of code or that line of code to set up the function the way I want. So those are a couple of the changes that are currently in the face right now that I've made little tweaks on. What we're going to do is we're going to come back and I'm going to show you how to get this eyebrow working as I've shown you.